Okay, so we're looking at trig functions of the general angle. So angles in a right-angled triangle are always acute because they have to be less than 90 degrees. If you have more than, if you have two 90-degree angles, you're never going to form a triangle. So, however, we do get obtuse angles, and we get them used in many situations in trig, such as bearings. And we also talk about negative angles in engineering and sciences. So the positive direction of the x-axis is the ray represented by the angle 0. So what that's saying is from the centre of my circle here, if we think about where the x-axis is, okay, the positive side of it is the angle 0. When we then start to create an angle in an anti-clockwise direction, we always go anti-clockwise, we're still going to be in the positive. Okay, so negative angles would be if we measured downwards. So if I was talking about a negative angle, then from x, I'd be going down rather than up. So if we've got a unit circle, what a unit circle means is that the radius is 1. So on the unit circle, this would have a value of 1, y would have a value of positive 1 up here, down here it would be negative 1, out here it's going to be negative 1. So we've got a radius of 1. So if we think about acute angles in the first quadrant, okay, then you will notice that x and y are both positive. So if I was to plot, if we think about this triangle that we've got here, okay, then the hypotenuse is 1 unit long because it's the radius of the circle. The x value of that coordinate there and how far along x is, how far along x is and the x coordinate is going to be positive. So x will have a positive value along the x-axis. Let me just get rid of that green. Okay, so x is going to be positive and y will also be positive. So if we think about our angle theta then, we can say that opposite over hypotenuse, which is sine, would be y over 1. Which is going to give us a positive value. Cos would be x over 1 and tan would be y over x. All of those are going to be positive values because x and y are both positive. When we start to extend it, we then start to have some negative angles. Okay, so that's what that's telling us is that sine theta is y over 1, which is equal to y, and so on. We then have down the bottom here, you've got where your positive angles are and where your negative angles are. So if we measure from the x-axis, which is always the positive x-axis, I should say. So from the positive x-axis, if we're measuring our angle, when we go anti-clockwise, we're measuring a positive angle. When we measure clockwise, we're measuring a negative angle. Okay? So this angle up here, if we think about what this angle here is, it could be plus 70 degrees, or it could be that we've gone the whole way around in a negative direction to negative 290, or it could be that we've gone around all the way to 360 and then added another 70 degrees. Okay, so it could be 430 and so on and so forth. Does that make sense? Yeah? Okay, we're not worrying about exercise 5D. What is in 5D isn't really relevant. The textbook got a bit carried away with what it was doing. We are going to have a look at quadrant, sine, and the related acute angle. So when we were talking about that first quadrant, and we worked out our sine theta, which was opposite over hypotenuse, and cos theta, and blah, 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 all of the angles, all of our ratios, I should say, are positive. Okay, so all ratios are positive in the first quadrant. Now, if we were to create another acute angle, let's say out this way, okay, and if we think about our angle here, what is, at this point here, where it intersects with the, actually no, never mind that part. Let's say, so if that's -1, this might be negative, let's go 0.7, right? That would be my x value. My y value, is my y value going to be positive or negative?
Negative.
Positive, because we're thinking up. The y value would be positive. Okay, so this might
Yeah.
be positive 0.6. Okay, so if we think about this angle in here, theta, I'm just going to call it theta for a moment, then if we think about sine, cos and tan, so sine theta is opposite over hypotenuse, which in this particular one would be my opposite side is my
0.6.
opposite, is the 0.6 and the hypotenuse is 1. So sine is still positive, right? Cos, hey?
Negative one?
No, because it's a distance.
Oh.
It's the
Yes.
unit circle radius.
Yeah.
Yep, so hypotenuse. Okay, so cos is adjacent over hypotenuse, which is going to be my negative 0.7 over 1, which is going to be negative. And then when we have tan, it's opposite over adjacent, which would be my 0.6 over negative 0.7. So it's also going to be negative. So the only ratio that is positive in that second quadrant is is sine. Sine. So that's what that S is sine. In the third quadrant, if you did the same thing again down here, both x and y are going to be negative, right? So that means that sine is going to end up being negative because it's going to be our x over y. X over 1. Cos is going to be negative because it's our y over 1, or round the other way. But tan ends up positive because it's negative over a negative. So it ends up being a positive ratio. And then the fourth quadrant, cos is the only one that's negative. Positive. Oh, my Lord. Okay. So this ASTC is just...
It's all positive.
All. Yep. So it's just a way to remember it, and you sometimes will see all stations to central as a way to remember it. Okay, so a train taking all stations to central. It's just a way to remember, but you can always just quickly think about your unit circle, think about opposite over adjacent or whichever, to try and figure out whether it's going to be positive or negative in that ratio. So first quadrant, and then work in a anti-clockwise direction as you do when you're measuring your angles. So that is saying that in this first quadrant, all ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tangent or tan is positive. And in the fourth quadrant, cosine is positive. So now we're going to grab out a calculator because we're going to be doing some graphing. So what we're going to look at is we're going to look at curves. So we're going to look at the sine, cos and tan curves. So what we need to do is we need to graph the trig function between a particular domain. So we're given a domain of negative 360 to positive 360. Our graph here is nicely broken up into 4 sections. So we're going to go negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270, 360. Okay, so make sure your calculator is in degrees mode, so you should have a little D up the top. And then let's start with sine negative 360. So when you put in sine, I'm trying to find the negative 360, and you get 0. So we're going to plot a point there at 0. Then put in sine negative 270. And you get 1. Sine negative 180. We get 0. Sine negative 90. So all I'm doing is putting these values in and we get negative 1. Okay, sine 0. You get 0. Sine 90, you're going to get 1. Sine 180, you'll get 0. 270, you'll get -1. And 360. One thing I didn't do was label my x-axis. This is going to be 1. This is going to be -1. Now, it's a bit hard to see the shape of what's actually happening here. So you could always put in some more values, because although it looks like it's going in like straight lines, it's actually a curve.
So it's always a curve?
Sorry? Yeah, this is the sine wave or the sine curve will always be a curve. So this gives you your basic shape, and it's kind of looks a bit parabolic in the way it comes up and it comes down and then comes up, whoops, and then it comes up and it comes up and it comes down. If you want to have a look at what it looks like a lot neater than what I can do, go to Desmos and put in y equals sine x, and you will see the curve, and you'll see that it continues on and on and on and on and on. Okay, so we've just looked at it between that domain. So that is what the curve of sine x looks like. So important point to note with sine x is that when x is equal to 0, our sine curve starts at y is equal to 0. Okay? The reason why I want you to notice that is because it matters with the cos curve next. So with sine x, you start at 0, 0, and then you go on in the positive direction.
So you start negative and work your way?
Yeah, well, I would probably start at 0, 0 normally
Oh, okay.
and draw that part of the curve in and then work backwards,
Oh, okay.
kind of thing. You can put in more values than that. We can do transformations and things to it as well, which we're going to have a look at. Where does it, how far is it before it looks like it's going to repeat itself? Or when does it, how frequently does it repeat itself?
When it gets to the x. No, when it every
does
five.
it one up and down.
Yep, and so that's going to keep going, right? So if I just move this over for a moment, oh, wait, you need to go with that, thank you. So if I was to continue this on, it would keep going up and then down and then up, and it would keep on going and going, okay? So at this point here, if we started there, where does it reach that point again? Well, it's here.
So it's like every 5 years.
So it's every 360 degrees, it's repeating itself.
Is that standard? Or
Yeah. For the sine graph, yes.
Yeah.
That's when it says y equals sine x, it will always repeat itself
just
then.
like a circle?
Have a think of, yeah. Now, let's think about when we did the unit circle just before, and we said all stations to central. Thinking about, so this is angles between 0 and 90. Oops, you can't quite read that. So the first quadrant is angles between 0 and 90, and we said that the sine graph was positive. This is angles between 90 and 180, and we said that the sine graph was positive. Right? So what that's actually telling you, how that relates to this graph is, look, our sine graph is positive, so it's above the x-axis between 0 and 180. And then it's negative between 180 and 360.
Just proving
Yeah.
okay.
Yeah, it's another way to look at it. We tend to do more, we do a lot sort of with the graphs. All right, so now let's do the cos graph. So we've got to do the same thing. So we're going to set up our axis with our negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270, 360. And I'm going to let you know that the highest it's going to go to is 1 and negative 1. So it's going to go between negative 1 and negative 1. So then we're putting those in. So if I put in cos 0, I get 1. So straight away, what's different? Think about where sine x was when x was equal to 0.
0, 0.
Yeah. So straight away, we've got a difference. So then if we put in cos 90, we get 0. Cos 180, we get negative 1. Cos 270, we get 0.
And they get like super complex.
Yeah. All right, so cos negative 90 is 0. cos negative 180 is negative 1, cos 270 is 0, and cos negative 360 is 1. So here's our curve. Oops, roughly like that. We might have a look on Desmos so you can see what the curve actually looks like, because I'm a bit crap at drawing. And that's our curve for cos. How would you say it's different?
It's like a D, it starts up.
Yeah, it does start up. Realistically, it's just been shifted, right? But think about our quadrants. So 0 to 90 degrees is the first quadrant, and cos is positive there. Between 90 to 180 is the second quadrant, cos is negative. 180 to 270 is the third quadrant, cos is negative. And then that fourth quadrant, cos is positive again. Okay, so that can sometimes help you with working out whether your answer is going to be positive or negative, is thinking about where it sits on that curve as well. Realistically, they're very much the same, except they've been shifted. So this one, so our sine graph is like at 0, 0. If you shift that 90 degrees, they then, no, not 90 degrees, 180 degrees. And we want it going up. Yeah,
If you
so
shift
90
the bottom
degrees.
190 degrees.
Yeah, 90 degrees across, then they follow the same pattern. All right. Tan is completely different. Okay. So, have a think about y equals tan x. So, I'm trying to think how best to explain this. Look at the previous page. You had that sine theta is equal to y, because remember it was the opposite over hypotenuse, so it was y over 1. So sine theta is equal to y. Cos theta is equal to adjacent over 1, so it was equal to x. Now, tan theta, hey?
Equal to Z.
No. So think back to our unit circle, right? So if I've got this angle here, this is my theta. So we're saying that this is x, this is y. We've now said that y is the same as sine, is equal to sine theta, not sine x. And x is the same as cos theta.
So just be Y over X.
So tan theta is equal to the opposite over the adjacent side, which would be equivalent to y over x, which is equivalent to sine theta over cos theta. Does that make sense? Yeah? So this is one of the sort of identities. So tan theta is equal to sine over cos. Okay, so that then means that what can cos theta never equal?
0.
0. So anywhere that cos theta is equal to 0, we're actually going to have an asymptote. Right? So thinking about our cos graph above, okay, so from our cos graph, we had that. I'm just going to do some highlighting. So, my graph's moved. Trying to get that down to the right spot. It's good enough? You get the idea? Okay, so cos theta, wherever it is equal to 0, which is here, essentially where it intersects the axis, here and here. So at those 4 points in our tan graph, we're going to have an asymptote. We're not going to be able to get a value because we can't have cos theta equal to 0. So what that gives us then is an asymptote at negative 270, negative 90, positive 90, and positive 270. They're going to be asymptotes. Put into your calculator, so that was, I should label my axis. put into your calculator those values that we haven't got a value for yet. Oops, that's not 90, that's 180. And that's not 270, that's 360.
So do we just go
So
10,
what's...
negative 360?
Yep, so what do we get when we put in 10, negative 360?
0.
0. What do you get when you put in 10, negative 180?
0.
0. And then the next 0 will be 0, 180 will be 0, and 360 will be 0. That's not giving us very much information at the moment. So try 10, negative 350. Let's go like right here. So just before negative 360.
10 negative.
Negative 350.
0.1763.
Okay, so it's slightly positive. What about if you put in 10, negative 275?
11.43.
Okay, so it's getting to be quite a big number. So it's like up, it's going way up here somewhere. So what we've actually got happening is a curve there. Now we can repeat that. So what happened if we do, let's do it in the positive section so it's a bit quicker and easier. This is negative 90. What is, no, it's positive 90. What is 1095?
Negative 11.
Okay, so it's all the way down here,
Same but negative.
all the way down here somewhere. What is 175?
Negative 0.0.
Okay, so it's just below the axis, it's kind of here. What about 10, so there's my 270. What's 265?
11.
Right, so it's a big positive one. So what's actually happening is we've got a curve that looks like this. And it continues on in both directions. And it actually repeats. So it kind of looks like this.
It's just that they're not connected.
They're not connected because there's an asymptote, so there's discontinuities. And so we've got all these different graphs for the tan graph. So now we're having a look at our inverse functions. Okay, I'm just going to go to a pencil for a moment and think what did our sine graph look like? Started at 0, 0,
Ended at 0.
and it went up to 1, it came down.
Yeah.
Whoops, that's really dodgy, but you get the idea. Okay, so there's my sine graph. Okay, that's now going to help us because what is cosec? What is cosec? 1 over sine. So we're looking at, whoops, go to pen. We're looking at y equals 1 over sine x. Okay, now what's going to happen then? Are we going to have a continuous graph, or are there values that we can't have? We can't have a graph at sine x equals 0. Okay, so anywhere that sine x equals 0, we're going to have an asymptote.
So it's similar to what we just did.
Similar-ish.
In the sense that it's not connected.
Yeah, we end up with... Right, let's quickly see if I can open up Desmos. Right, so this is Desmos. So if we put y equals... we want cosec, don't we?
Yeah.
Cosec x. This is what our graph looks like.
What's that?
Yeah. So what actually happens is it kind of gets inverted. All right?
And then like at the bottom
It just continues on. So what's actually happening is it's coming... And you can put some values in and see what's happening. So let's put in 1 over sine negative 90.
1 over sine neg 90.
Yeah. Negative 1. Not sure about that. Okay, so what about if we had negative 85? That's going to be funny.
85.
Yeah, negative 85.
Negative 1.0038.
Negative. Okay, so that is down here somewhere. Oh yeah, that's right. Okay, so you can, what you hopefully recognise then is that it's actually going like this. Whoops, I did that poorly. Okay, so then here it comes like this. I should have done my graph very differently. Sorry, I kind of put it off the chart.
So should we draw that on the chart?
Hey?
Draw that on the chart.
Yeah, well, yeah, so really I should have put my ones lower. Let's have a look at the second one. We'll do sec x a bit better. So let's start by drawing our cos curve. So where does the cos curve start? At 1. So we're going to I'm going to go to just negative 1 here. All right, so when I sketch it in, it goes from negative 1, it then goes down to 90, up, and then down to 0, down. Oops, that is poorly done. Okay, that's really bad, I'm sorry. One continuous graph. Okay, and so then our cosec graph does the same thing as the sec graph. Sorry, our sec graph does the same thing as the cos graph. And what it'll actually look like, it looks like a mirror image that doesn't, oh, sorry, this should be in pen, not pencil.
Is this how we're drawing it, sorry? Yeah. Good, let's shuffle that.
Oops.
Yeah, I loved graph drawing. It's just created so many plots.
All right, so that's what and that one goes like that. And so that is our cosec graph.
Could you
The-
cut a little bit, please?
Oh yeah, sorry. The cot graph ends up being a mirror reflection of it. All right. I'm going to leave question 4 for now, or the next example, which is sketch y equals 4 cos 2x. You might want to set up a table of values. So choose your 4 values and have a look at it, or put it into Desmos and have a think about what's happening with it. I want to get into these examples where we're finding exact values. Okay, so find the exact value of sine 300. So first of all, we have to work out which quadrant it is in. So 300 degrees, you can either think of it as negative 60, or you can think about, okay, well, 300 degrees is going to be all the way around here somewhere. Okay, and it's going to be in my 4th quadrant. So sine 300 degrees is equal to negative sine, because sine is negative in that 4th quadrant, 60 degrees. So 360 minus 300. Okay, so see where that's come from? Now, negative 60 degrees is one of our special triangles that are on your reference sheet that I can never remember exactly either. Once I teach it a bit, I get better at them. Okay, but it's on your reference sheet. So quickly draw the angle that's got a 60 degree, which is 60, 30, 1, 2, root 3. Okay, now we want sine 60 degrees. So we're looking at this angle here. Sine is opposite over hypotenuse. So it's negative root 3 over 2. Whenever you see exact, because this asks us for the exact value, you're thinking, try and think, particularly in trig, when you see exact value, think, can I get it to 30, 60 or 45 degrees? Because if I can use one of my triangles. Okay. So now we're going to have a go at these questions. So find the exact value of tan 330 degrees. So we're actually looking at, so think about how they set it up in here. Which quadrant's it going to be in?
C again.
It's going to be in the fourth quadrant. Okay, so for question 1, we can say in fourth quadrant. Okay, so therefore, sine 330 degrees is equal to, is tan, oh sorry, we're not looking at sine, we're looking at tan. Is tan going to be positive or negative?
Negative.
So it's going to be negative 360 minus 330. Okay, so we're looking at negative 30. Now, thinking to our triangle, here's my 30 degrees. Tan from 30 is opposite, so it's 1 over root 3. So it's going to be negative 1 over root 3. It's often a good idea to rationalise your denominator. Okay, so times by root 3 over root 3, which will give you negative root 3 over 3. Question 2, so find the exact value of sine 225 degrees. So think to yourself, 225 degrees, which angle is that going to be in? It's going to be in the third one. Yes? Because it's more than 180, less than 270. Sine is going to be what? Positive or negative?
Negative.
Right. Negative, because we're in the third quadrant. So if you need to, you can put your A, S, T, C. Sine's going to be negative. So for question 2, we're going to say it's in the third quadrant. So therefore, sine 225 is equal to negative it's actually going to be, hey?
I don't know, the 360.
It's kind of weird the way they're doing this. So it's negative 225 minus 180. So it's probably a step that we've kind of missed. I think it might have been on a previous thing. So thinking about it again, so I've done it really dodgy. This is theta. The angle here is 180 minus theta. This one here is the angle minus 180. And this is 360 minus the angle. Okay? Does it make sense though? Because like if I had an angle here that's theta, then it's 180 minus theta.
So that first one, sorry, that's just theta.
Just theta. If I have an angle here, then it's the angle minus 180 that will give you what the included angle is. Does that make sense? Yeah? Okay.
Yeah.
All right. So now we've got sine 225 is equal to negative 45. Now we've got to think about our 45 triangle, the triangle that's got that piece of information in it, which look,
90, 45.
hey, yeah, so it's 1, 1, root 2. So sine for negative 45 is going to be negative 1 over root 2. And then we should probably rationalise the denominator, but hey, yeah, I'm trying to get through some. Okay. Find the exact value of cos 510. So what I would do for that question, for question 3, I'm going to move over here. So it's cos 510, isn't it? Okay, so that's equal to cos 510 minus 360. Okay, so take away the full revolution, which leaves us with $150. Okay, so which quadrant is 150 degrees in? Second quadrant. Okay, so therefore second quadrant. Okay, so therefore cos 150 is equal to 180 Oh, sorry, is it going to be positive or negative?
Negative.
Negative because it's cos, so it's negative 180 minus 150, so it's negative 30. Then we go to our triangle.
Same 30, 69.
Yep, so 30, 60, 1, 2, root 3. So 30 is going, and cos is going to be root 3 over 2. Am I right to move that over? I'm trying to find example 4. Okay. Question 4, simplify cos 180 plus x. All right. And I'll keep it in black. So we've got cos 180 plus x. So we're thinking about which quadrant 180 plus x is in. And it's in the second and the third. Right, it's just kind of right on the borderline. Okay, it's exactly... It's in that third quadrant, so it's going to be negative cos
Let's
x.
just say it was between the T and C. Would you do a positive or a negative?
So if it was like finding tan 270 degrees or cos 270
Yeah.
degrees,
Like,
it'll end up equaling 0.
okay.
Go to your graph.
Okay.
Think about what it looked like on a graph.
Mhm.
Okay. Find the exact value. So last question, find the exact value of tan negative 120. So we've got tan negative 120. So is tan, at this point, tan is actually positive. Like the coefficient of tan is positive. Does that make sense? So which quadrant is it positive in? Is tan positive in?
Third.
Yep. So tan is positive in third quadrant. So tan negative 120 is going to be equal to tan 240. What? That doesn't make sense. What am I doing to myself? Oh, because it's negative 120. So we're going from 360 degrees, we're going backwards. So if we go back 120 degrees, we're in the third quadrant.
So it's 240.
Yeah, so that's where our tan 240 comes from, which is equivalent to, so if we've got 240 that way, then this angle in here must be 60. So it's going to be equal to tan 60 degrees. And now we've got one of our angles that we can work with, which is going to be root 3 over 1, which is root 3. So with these questions, you're using your triangles, you're using your unit circle, you're going to be using your graphs a bit as well. So we will finish this exercise because we've got 3 minutes left now. So you'll have time tomorrow to work on those questions. And so that's the end of week 7.